I'll get started. Hello, everyone. My name is Mete Atamel. I'm a developer advocate at Google, based in London, and it's always great to be here in Rome. Today, I'm going to talk about gRPC, which is an open source RPC framework that was developed by Google, but it's open source and anyone can contribute today. So before I start my talk, this is my Twitter, my email, and my blog. So if you have any questions about any of the stuff I say today, feel free to reach out to me. I also have a feedback for my talk. I always like to make my talks better and better. So if you have any feedback about my talk, feel free to go to that link, and there's like a survey for that will take you like a minute or so. Feel free to send me any feedback you have. So the agenda we have today is first, my talks usually go with like why, what, and how. So I first explain why you should even care about gRPC, what's the motivation behind it. And then after that, I'm going to talk about what it is, what does it provide, and then finally, I'll show you how. So I'll show you the code and how it actually works. So we're going to talk about the gRPC basics, what are the design goals, what problem does it try to solve. After that, I'm going to show you the code, because I know most of you guys are developers, so you want to see how it works. Then we're going to talk about the benefits. So gRPC is based on HTTP2. It's based on protocol buffers. It supports multiple languages. So we'll talk about all the benefits that you get by just using gRPC. And finally, I'll show you some more code, hopefully, if you have time for that. Okay? So let's start with the regular procedure calls before we talk about remote procedure calls. So imagine that you have a service. It's very simple. Let's call it a greeter service that has a method called greeting that takes in a string and it returns a string. So it's very simple. If you want to use this from, say like a greeter client, what you do is you just create the service and you just call the method, right? Everything lives in the same machine. Everything, if it's Java, for example, everything lives in the same JVM. So you don't have to worry about network. You don't have to worry about how do I call things. You just make your call. Everything works. It's simple. Now, what is remote procedure call? If you look at the definition from Wikipedia, it's this long definition. But basically, what it means is that your service and the client, they're separated now. They are not on the same machine. Maybe your client is running on a laptop or a desktop or a mobile device, and your server is running somewhere in the cloud, and then they need to somehow communicate, right? So in this case, you have some questions to answer, right? First, how do clients call the service? Because now you have the network to go through. So do you make a regular HTTP service, or do you make a socket connection? So you need to think about that. Second thing that you need to worry about is, how does the service expose? How does the server expose the service? You want to expose the greeter service, but you don't want to expose everything you have. And maybe in greeter service you have a bunch of other methods. You don't want to expose all of them. You want to pick and choose which one you expose. So there are things to worry about there, like how do you actually mark the services that you want to expose to the clients. The other thing is, you are sending data over the wire, so how do you serialize the data? Do you use JSON? Do you use XML? Do you use a binary format? And whatever you choose, you need to serialize the data, you need to deserialize it on the other end, and so on and so forth. And the connection, how is the connection? Do you want to do a regular request and reply, or do you want to set up a socket connection where you have a full duplex connection? Depending on your environment, the choice might be different. If you're building, like, say, a stock application where you're getting lots of stocks from the server, maybe a TCP connection makes sense. But if you just want to request some updates once in a while, maybe a regular request and reply is enough. And finally, authentication. How do you authenticate? You don't want everyone to call your service. You probably want to have some kind of authentication. So these are the things that you need to kind of think and design for, right? So at this point, you have two choices. You can build your own RPC framework if you want. The good thing about this is that when you build your own RPC framework, it's basically exactly how you want it. And I used to work at Adobe, and I worked on Adobe Flex. I don't know, anyone use Adobe Flex here before? Okay, a few people. So Adobe Flex was like a framework to build Flash applications. And it had a server side called Adobe Flex Data Services that basically allowed you to expose your Java backends to Flash clients. So for Adobe Flex Data Services, I actually built an RPC system, and it was great because I built it with my team, and it was exactly how I liked it, right? But there were some problems with it later that I'm going to talk about in the next slide. But the negative thing about this is that you need to, all the questions that we had before, you need to answer them and you need to implement them yourself. So it's a lot of work. Or the second choice that you have is to use something like something open source, something like gRPC, where all these questions, they're already answered by the community and they're already implemented for you. So that's great. But the only downside for me in this case is that gRPC has its own style. So you need to buy into that style. So if you feel really strong about your code, and if you don't like certain styles of code, then gRPC might not be easy for you because it has its own style that I'm going to show in the code samples. So you need to buy into that. But by buying into that, you basically get all the benefits of the community and all the implementation that comes with that. So as I mentioned, I built Flex Data Services and RPC framework before, and it was great. So we started small, but we basically had a remoting service that exposed the Java classes on a J2E server. On top of the remoting service, we built like it's very hard to see here, but I'll try to describe. We built like a managed remoting service, then we had a messaging service, then we had, on top of the messaging, we built like a data management service, and then we had the serialization working. We used something called AMF, which was a binary serialization format, which was really efficient compared to JSON and XML. Then we built all these channels. So we built like an HTTP channel, HTTP polling channel, HTTP long polling channel. When WebSockets came along, we built a WebSocket channel. We even had a TCP connection using something called RTMP, which is like the protocol used in Flash video. So we built all this framework for Flex and Flash clients, and on top of that, we built like HTML clients, Java clients, everything over the years, over 2 or 3 years. And at the time, it felt right. You know, we need an RPC framework. Let's build our RPC framework, right? Then what happened is that in April 2010, Steve Jobs came along with his thoughts on Flash letter. Some of you probably remember this. So he basically wrote a letter and explained why Flash is never going to be on an iPad or iPhone. And it was, in some ways, it was technical explanation why, and in other ways, it was kind of political because he basically didn't want a third party on iPhone. And after this, our Flex and Flex Data Services and Flash kind of went away. You know, like Adobe switched focus from Flash to JavaScript and HTML, and all the work that we put into our RPC framework, it basically just went away. And I switched jobs and I started working somewhere else. I had the same kind of problems again, so we had to rebuild everything because we didn't rely on something open source, and so that's my story basically about building your own RPC services. So that's why I think you should think about whenever you're building something, you want to build something on an open source platform so that things like this don't happen to you, okay? And then at this point, you might ask, like, why don't I just use REST, you know? Like, we know REST, we know get, post, put, delete, and we know the semantics of how it works, so why don't I just use that? And my answer to that is that, you know, if you can use REST, go ahead and use REST. And if it works for you, then great, use it, because it's simple, it's well understood, so just use it. But gRPC makes sense when you need to deal with complex transactions. Like, for example, if you need to build like a banking system and you want to write a method of transferring money from one account to another account, you can do that with REST, but with gRPC, you can basically create a banking service and you can create a transfer method, and you can encapsulate all the REST that you have to do within that method. So that method can encapsulate all the complexity that needs to happen behind the REST. So I think for more complex problems where you have like domain-specific services and calls, gRPC makes more sense. gRPC also allows you to have strongly typed objects. So you define your service and you generate code for the server and the client. So that way you are dealing with actual like strongly typed objects. You're not dealing with HTTP calls. You're dealing with bank service. You're calling a method on the bank service. So everything is strongly typed, and I think that makes development much easier. And finally, and I guess the most important part of gRPC is efficiency. So with HTTP2 and protocol buffers, gRPC is really efficient. So if you need that efficiency, I think that's the way to go, right? So let's talk about the gRPC basics. So gRPC, it actually doesn't stand for Google RPC. That's what people usually think. It stands for gRPC remote procedure call. So the G refers to gRPC, it's like a recursive call. It's basically a high-performance, open-source, general-purpose RPC framework. And it started with something called Stubby. Stubby is an internal RPC framework that's used at Google. So the engineers who worked on Stubby, they looked at it and they learned from it, and they created an open-source version of it, and they just open-sourced it into gRPC. And it's out there, it's actively developed and used by people. The latest version currently, I think, is 1.2.0, but all the new versions are coming up all the time. So there's a website you can go and see the principles of gRPC. I think one of them, I won't go through them all, but to point out some of them. First of all, it's free and open. That's really important. It's layered, meaning you can, every layer of gRPC is layered and pluggable. So if you don't like something, you can easily plug in whatever layer you want. It tries to be general purpose, so it tries to appeal to all different kind of use cases and all different kinds of languages. It supports like streaming, blocking, and non-blocking kind of communication. And it relies on this idea of services, not objects, and messages, no references. So one of the fallacies of distributed computing is that once people have a service, they kind of treat it as a local service, as if it's running local on their machine. So they forget that it's a service that runs somewhere else, and they think of the service as like an object, and then when they make a call to the service, they think of it as making a call to that object. Whereas gRPC, it tries to avoid this fallacy by, making everything a service, so you think of it as something that exists somewhere else, and you pass messages to that service. So by having this construct up front, it basically helps people not to fall into this fallacy of distributed computing. All right, so how does it work? So basically, first you start with a service definition. So service definition, it defines what your service is, it defines what methods it exposes. It's written in protocol buffers, and I'm going to show you this pretty soon. So the good thing about service definition is that it's very clear. Like if you want to look at your service at the high level, it's very clear by looking at the service definition what your service is and what your methods are and what you're exposing. Now, once you have the service definition, you generate code from it. So you generate client stubs and server stubs as well. So the good thing about that is that the client has the code, the server has the code, so all the underlying protocol of how to make the connection between the client and the server is generated code for you. So you don't have to worry about that. And then all you need to do is you extend from this code and add your own logic on top. So you have, as I mentioned before, you have efficiency in serialization because we are using protocol buffers. So it's a binary protocol that's much more efficient than JSON or XML. And you have the connection efficiency because we're using HTTP2. And I'll talk about these efficiencies later in the talk. And then you have options when it comes to connections. So you can have what's called unary connections. So you can do this simple request and reply. You can do client-side streaming, where the client sends lots of requests to the server, or you can have a server-side streaming, where the server sends lots of requests, responses to the client. And then you can have bidirectional streaming, where the client and the server at any time can send messages to each other. So depending on what you need to do, there's options. And then finally, you have authentication options. So you can use the SSL and TLS, but you can also use token-based authentication. So this is how it is at the high level. Let's just look at a picture. So you can have let's say you can have a Java service that's running a gRPC service. So the part of the code of this gRPC service is generated from the service definition. And then you can have all sorts of clients connecting to the service. So you can have a mobile app and a laptop connecting to it. Again, there are stubs. So gRPC stub is generated from the service definition and talking to your service. You can also use gRPC for service-to-service calls. So maybe your gRPC service is calling some other service, but this time it's Python. But gRPC doesn't care what language you use, so there are generators and codes for pretty much all languages. So the Java service can use the stub that's generated to talk to the Python service, and the Python service can talk to other services, maybe a C++ service or a Golang service, again using the stub. So as you can see, the connecting clients to the services and connecting services to services, it can all happen through gRPC, and gRPC gives you, like basically gives you all the options that you need in terms of the connections, in terms of the generators for all the languages, okay? So let's look at the code now. So how do you create a hello world service using gRPC? That's what I'm gonna show right now. It's basically just 4 easy steps. First, as I mentioned, you need to create a service definition, right? So in this case, let's create a service definition called greeter.proto. First, we define our service. We will call this we'll call this service greeting service. It has a single method called greeting. We mark it as an RPC method. So this is an RPC method, and it takes in a hello request and returns a hello response. So right now we don't have the definitions of hello request and hello response. So let's define those. So the hello request, it's a message. Remember, in gRPC, everything is a service, and you exchange messages between services. So in this case, hello request message, it just has one string called name, and that's it, nothing else. You can have more here. This can be as complex as you need to be. So these messages can be as complex as you need them to be. But in this case, it's just a string. And then response, again, it's also just a string. But this also can be as complex as you need. So basically, this greeting service takes a string, returns a string. That's the thing. So once we have this definition, now we need to generate code. So if you're a Java person, you can use protobuf Maven plugin for Maven, or there's also a protobuf Gradle plugin for Gradle people. So you basically point this plugin to the service definition, and this generates the server code and the client code that you need. If you are a .NET person, then there's something called gRPC tools NuGet package that you can install, and then that comes with Proto-C compiler. So the Proto-C compiler, basically, you just point to your Proto service definition, and from there you get all the code that you need. So we have our service definition, we have our stubs. Now you actually need to create your own logic now. So first what you need to do is you need to create a server. So what you do is you create what's called a service implementation. So your server is generated code, but on top of that, you create a service implementation that has your own logic. And then you create a server with the port and your service implementation, and you start the server. So that's it for the server. Servers are usually pretty easy. The service implementation is what you actually need to work on. And I'm going to show the code shortly. And then creating the client is a little bit more complicated because first you need to create a channel for the client. So the client has to pick the way it needs to talk to the server. So the channel basically encapsulates the type of the connection that the client is going to have to the server. Then you need to decide whether you want your calls to be blocking or non-blocking. In some cases, you want to wait for the response from the server before you can continue. But in some cases, you want an async response. So you just make the call and wait for a response whenever it comes. So you make the choice. Then you create a request, you send the request, and then you just handle the response. So that's it. These are the 4 easy steps. Let me show you this in Java quickly. So here I have Eclipse open. And I have a project with greeter, client, and server. Let me just sit down. So let's look at the server first. As I mentioned, this is a proto file that defines my service. So this is my service that takes in a request and it returns a response. Now the request in this case is a little bit more complicated. So I have the string name, but then I also have age as integer. I have hobbies. Repeated means basically a list in gRPC. And then I have bag of tricks, which is basically a map. And then I have sentiment, which is an enum. And then if you look at my proto, at the top, the sentiment is basically happy, sleepy, angry, just something simple. So my request is basically about a person with the name and age and sentiment, stuff like that. And the response is just a string with greeting. So I define what my requests are, what my responses are in this proto. And then if you look at my POM, here you'll see that I'm using the protobuf Maven plugin. So by using this plugin, I'm basically looking at the greeter.proto and generating all the code, okay? And if you actually look at under target generated sources protobuf Java, you see that all this code is generated. So this is the code that you don't have to write. All this code basically defines how the client and server communicates. If you look at the code, and by the way, I don't recommend you looking at the code because it's ugly, as in every generated code. But basically, the greeter has the basic code. It doesn't make sense when you look at it, but it's very easy to use. So I'll show you, instead of looking at the generated code, I'll just show you how you use it. So let's look at the server first. I have this greeter server that I created. So what you need to do is basically 3 easy steps. First, you need to build a server. So for server, what you need to use is a server builder. As I mentioned to you, gRPC has a style for everything. So the style that they're using is the builder style. So you have basically builders for everything, and you set things on the builder, and then you get what you need from the builder. So in this case, we are using server builder, and we are specifying a port, and then we are adding a service. So this greeting service implementation is what your logic is. That's where you're going to define things. So I built my server, and then I start my server, and then I just make sure that my server is running. So that's it. There's nothing fancy here. This is the guy that will have the logic that we need. So if we look at the greeting service implementation, first what you're going to notice is that it extends from this base class. So this base class is generated code from the proto. And then all you need to do is just overwrite what the base class has. So the base class has this abstract methods that you need to overwrite. So in this case, the abstract class is only greeting method. So what I'm doing here is I'm overriding the greeting method. I'm getting a request. And then response observer is basically my response to the client. So what I'm doing is I'm just receiving a request. And then from the request, I get the name. And by the way, from the request, as you can see, these are now all strongly typed, so I can see get age, get bag of tricks, get hobbies. So they're all strongly typed, so that's the good thing about gRPC. But what I'm doing is I'm just getting the name from the request, and then I create a response. As you can see, again, we are using the builder, so we are getting the response, getting the builder from it. We set a greeting that I'm basically just getting the person's name and just saying hello there, the person's name. And then I get the response from the builder. And then what I need to do is using the response observer, which is my connection to the client. By doing on next, I'm sending my response to the client. And then you need to, if you don't have any more messages to send, you need to call on completed. So I'm just saying, okay, send this response and make sure that it gets to the client. So that's what that is. So this is the server. And let's just take a look at the client really quick. So the client, I only have one class called greeter client. So as I mentioned, first you need to define your channel, your connection to the server. So we create a channel. Again, we are using the builder. So we have this something called manage channel builder. So I'm saying create me a channel with the host, which is localhost in this case, and the port. And then use plain text means don't use SSL because this is just a demo. So I'm just using regular HTTP. So I get my channel. From my channel, I create a stub. Stub is basically like a client that you use to talk to the server. So when you make a stub, you have a choice to create a blocking stub or non-blocking stub. So in this case, when I make a request to the server, I want to get a reply, so I want to block. So what I'm doing is I'm using this greeting service gRPC. It's generated code, and I'm getting a blocking stub from it and passing the channel. So I'm just saying that use this channel and give me a blocking stub. So once I have the stub, I can talk to the server. But before I do that, I create a request. So my request, again, from the builder, I set my name, I set my age, I set my sentiment, and then I get my request. And then the stub, I just call greeting on it. Again, as you can see, this is strongly typed. So the stub has all the, if you have more methods here, you'll see them here because it's strongly typed. And that's why I like it, because you don't have to guess with HTTP. You have to guess what you need to create, but here everything is like strongly typed. So I just sent the request, and since this is a blocking request, we'll wait for the response. So it will block here, I'll get the response, and I'll just print that out. So let me just run this quickly before we move on. So I start the server. So the server is running on port 551. And then let's call the client. sending requests, and it receives a response. That's it. Nothing fancy, but it shows you that it actually works. So let me just go back to my presentation. All right, so now that we see that it works, let's talk about the benefits of gRPC. So why should you even consider using it? So there are, I think, four main benefits. First is using HTTP2, and HTTP2 is really important for low latency transport, and I'll get into more details of that in the next slide. It's using protocol buffers that gives you efficiency in serialization, and I'll get into details of this as well. It supports all the languages. That's very important because, as you've seen in my experience, before I built an RPC service for Flash, but when Flash went away, the whole thing went away. So it's important to have that multi-language support. And then you have the connection options. So depending on what kind of connections you have that option. So these are the main benefits. Let's talk about HTTP2 because I think it's really important. So if you look at the history of HTTP, it started with like 0.9 in 1990s. Then we had HTTP 1.0 that came up in around 1997, 98. And then we had an update to HTTP 1.1, again around the same time frame. And then it's been used since then. So I think if you look at this, HTTP 1.1 is a really successful protocol because I don't know many things that survive that long if you think about it. But HTTP 1.1, it has some problems, right? First, the parallelism in HTTP 1.1 is limited. So for every HTTP connection, you need a TCP connection, especially in HTTP 1.0. So that means that the number of parallel HTTP requests that you can have is limited to the number of TCP connections that you can have, and that's very limited. The other problem you have is the header line blocking issue. So in HTTP 1.0, if you need to make multiple requests, what you had to do is basically send a request, wait for a reply, send another request, wait for a reply, send another request, wait for a reply, and this wasn't efficient. HTTP 1.1 introduced pipelining. So the idea in pipelining is that you send multiple requests all at once and then get responses all at once. So this is how it is supposed to work. But if you look at how it works in HTTP 1.1, it kind of works like this. So you send all the requests, but you need to send responses back in order. So what that means is that you need to wait for this guy first before you can reply to others. So you still need to wait, like for this one, for example. So if this response takes a long time, then these will take a long time just because they had to wait for it. And then HTTP 1.1 or 1.0, it had a lot of overhead with the headers. So the HTTP headers, we had lots of headers. They were sent all the time. They weren't uncompressed or anything like that. So we realized all these problems at Google, and we started working on something called Speedy internally to solve most of these problems. And this basically turned into HTTP2. So it started at Google, and then it basically became a standard, and that's what HTTP2 is today. So the idea with HTTP2 is it was released in 2015, and it tries to basically address all the problems that I showed you about HTTP 1.1. So it tries to address like latency, header line blocking issues. You don't want to have multiple connections. You want to have a single connection, and you just minimize the overall protocol overhead. Basically, that's the goal of HTTP2. So in a nutshell, basically, in HTTP2, you have a single TCP connection where all the requests are basically multiplex. You don't have the header of the line blocking issue. There's this new binary framing. So in HTTP 1.1, you had the headers and the body. They were all one. But in HTTP 2, we basically split that into headers frame and data frame, and they can independently travel over the same stream. We changed the notion of requests to streams, and I'll show you in the next slide what that means. And we compress headers. We don't send headers all the time anymore. So to talk about streams and messages and frames, basically, the client and the server, they set up a stream to exchange messages. And over the stream, you send messages. So messages are one or more frames. So message kind of defines the request and the reply. So they're like the combination of frames that define a request and a response. And the frame is like the smallest unit within a message. So you can have multiple frames within the message. So what this looks in real life is something like this. So you have the client and you have the server. There's a single connection. You have multiple streams over the same connection. You have multiple frames within each stream, and some of the frames are for the headers, some of the frames are for the data. But the beauty of this is that there's only a single connection, so you don't have to create new connections all the time, and everything is multiplexed over it. So you don't have to block or wait for others. Everything just works over a single connection. And let's just talk about the header compression quickly. So the problem in HTTP 1.1.1 or 1.0 was that their headers weren't compressed and they were sent all the time. In HTTP 2, let's say you have this request. When you send the request for the first time, you're going to send the whole thing because the client hasn't sent any of these headers before. But let's say the second request looks like this. If you look at it, it's pretty much the same as the first request. The only thing that's different is the path, right? So what HTTP 2 does is basically it will just send what is different. So it will send the path with the resource, but the rest will be, it won't be sent because we already have an index for the rest of the headers. And that's great because you're sending much less compared to before. So what this means for you is that basically images load like this rather than like that. And there's actually a cool website. Let's see if it works. If you go here, http://demo.io, you will see this in real time. And actually, conferences are a great place to try this because the Wi-Fi is usually not that great. So let's refresh this. So in HTTP 1.1, this took 1.3 seconds. And then let's run the same thing in HTTP 2. It's 0.3. So you can see it yourself that it actually works. All right, so this is HTTP 2, and now I want to talk about protocol buffers. I told you protocol buffers are really efficient. So just to give you an example, at Google Cloud, we are using gRPC for some of our services. So we switch from a JSON-based endpoint to a gRPC-based endpoint, and these are the results. First, the throughput basically increased 3 times with gRPC. And the other impressive thing was that the resources that took to generate the throughput was 1/4 of regular JSON. So you not only have more throughput, but you do that with much less resources. So that's what it means, like using protocol buffer compared to JSON or XML. Okay. And then gRPC supports all these languages. And if there's a language that's not supported, you can easily add it because it's open source, and it's supported on these platforms. All right? So let me actually show that this works. So I have the same example that I showed you before, but instead of running it in Java, let's run it on .NET. So I have my server. I think it's already running. Yeah, so my Java server should be running still. Now here I have Visual Studio, and I created the same application, the greeter client and the greeter server, just to show you the code. The code looks very similar because C# and Java are very similar, except C# is better. So in C#, same thing. I create a channel. So this says that the channel is insecure. So that's the plain text thing in Java. Then I create a client. So this is the stub. And then I create my request, just like before. But in this case, my request is from C# rather than Java. And then I send my request. And I just shut down. So it's pretty much the same code except in C#. To generate the code, underlying code for gRPC, I use protoc.exe that comes with the NuGet package that I mentioned before. So let's just try to run this. I think this is the server. So if I did this, yeah, it's already done. So basically, it's very fast. Maybe I do it again. But it sent the request and received the response. I mean, this shows you that it is indeed multi-language support, and depending on what language you use, you have everything you need. All right, so let me go back. And I talked about the connection options. So you have unary connection. That means the client makes a request and gets a response, and that's how it goes. If you need to do server-side streaming, where the server is sending lots of requests all the time to the client, you can do that. If you want client streaming, where there's a connection open for the client to send updates, you can do that. Or if you want to do bidirectional streaming, that's also possible. So for example, if you need to build like a chat application, you can use bidirectional streaming where the server and the client, they can send two messages each other all the time. Let me see if I have time. I think I have 5 minutes. So maybe in this 5 minutes, I want to show you a streaming example. So what I want to show you is I mentioned the chat application. In a typical chat application, you want the client and the server to be able to send messages to each other all the time. So let's see how you can do that with gRPC. I'll go back to my Java, and I'm going to do this quickly. So I have this thing called chat server. So as you know, we always start with the service definition. So in this case, my service is called chat service. It receives a chat message, and it returns a chat message from the server. So it's basically a message. One thing that you're going to realize is that we mark these as stream. So by marking these messages as stream, you are making them, so it's marked stream on the client and it's marked stream on the server, so you're basically creating a bidirectional stream. So that's all it takes to get this streaming behavior. And then the chat message is basically a message from, so that this is the name of the person and this is the message. And the server, it basically timestamps the message, so there's a timestamp. And then it just relays the message. So when the client sends the message, it timestamps it and sends the message back to connect the client. That's all it does. And if you look at the server, it's very similar to before. So you build a server, you start the server, that's it. The service implementation is where the logic is. So if you look at the service implementation, this again extends from a base class. So this is the generated code. Now this time, it's a little bit more complicated. So first, there's this notion of observers. So these are the connected clients that I'm going to get. What I'm going to do is when I get a chat message, I'm going to add my observer to the list of my observers. So this is going to be my list of connected clients, basically. And then I need to create and return a stream observer. So stream observer basically defines what happens when I receive a chat message. So there's a method that you need to override called onNext. So this is when you get a message from the client. What I do is I create a message, the server message. I set the timestamp, and I set the value of that message to the same message I received from the client. And then I go through my observers, and then I just pass my message. So basically, all I'm doing is, when I receive a message, I timestamp it and then pass it to the connected clients. That's all it is. And then there are methods of onError and onCompleted. You need to do something here normally, but I'm being messy here because it's a demo. And then let's look at the client quickly. So this is a Java FX client. So the client has lots of UI code, but we can ignore all of that. So there's there's setup and show primary stage, but we can ignore all of that. What matters for gRPC is that you, again, create a channel. This is how the client is going to talk to the server. You create a stub. Now this time, the stub is not blocking because I don't want my UI to block when I'm calling the server. So this is a non-blocking stub. So I have this chat service, and then I just call the chat method on the service, which gives me a stream observer. And then I'm going to basically listen on this stream observer. So I have these methods again, just like server, onNext, onError, and onCompleted. OnNext means when I receive a message from the server. So when I receive a message, I basically call some UI code to update my UI. And then onError and onCompleted, I just display some messages. So that's it. And let's just run this quickly. So let's run the server first. Server started. The client. So I guess it makes sense to start two clients so they can talk to each other. So we have two windows, and let's call this Java guy. Let's call this, I should have done this in C# as well. And this guy says something. And as you can see, as soon as this guy sends it, this guy gets it, and then same thing here. There you go. So it's bidirectional streaming because like that's what we wanted. All right, so let me go back. All right, that was it. Thanks very much for your attention. And as I mentioned, if you have any feedback about my talk, please go here. If you want to know more about gRPC, that's the main link. And if you have any questions after today, my Twitter, my email, and my blog. Thanks.